Hello again. We are moving on in our last unit of study talking about the derivative and differentiation. We're going to move on and talk about instantaneous rates of change, which are different from average rates of change, which we discussed in the last lesson. So this is lesson 12.2, so let's get started. We're going to look at the graph of y equals x squared, and there it is. And I've got 2 points that are red and joined together by a red line. You can see that the average rate of change between x equals 2 and x equals 3 would be the slope of that red line segment that I just created. So that would be 3 squared minus 2 squared. And the reason I'm squaring them is because that's what the function is. It's y equals x squared. So to get my y values, I square each x. So it's 3 squared minus 2 squared on the top, and just the x's, 3 minus 2 on the bottom. All right, and that equals 5. So the average rate of change from x equals 2 to x equals 3 would be 5. That's the slope of that line segment. But what if I wanted to know instead the instantaneous rate of change at x equals 2? So now I'm looking for slope at 1 point instead of 2. Well, how do I do that? You can't do rise over run if you've only got 1 point. So what I could do is I could find the slope between x equals 2 and a point that's very close to it. And as the points get closer and closer together, the slope at 1 point, at that one point where x equals 2, that will be more and more accurate as I bring those 2 points closer together. So let me give you an idea of what I'm talking about. I could calculate the slope between 2 and 2.1. And if I figure that out, I get 4.1. And what I did to figure that out was square each of those x's to get the y values, subtract those on top, and subtract the x values on the bottom, and I do my division, and I get 4.1. I could do the same thing between x equals 2 and x equals 2.01. Figure out the y values, subtract them on top, subtract the x values on the bottom, and I would get a slope of 4.01. And if I do the same thing between x equals 2 and x equals 2.001, then I would get a slope of 4.001. So you can kind of see the pattern as the second number gets closer and closer to 2, these slopes are getting closer and closer to 4. So I could probably guess that the slope of that red line that I've drawn that passes through x equals 2 would have a slope of 4. Okay, so let's talk about how to do this algebraically rather than looking for a pattern by plugging in a bunch of x's. So let's say I want to figure out the slope between x equals 2, that's where that red dot is, and x equals 2 plus h. And h is just a really small amount. I'm not giving it any value, but what I'm going to let it do is I'm going to let h get really, really small and see what happens as it approaches the number 0, meaning that the space between 2 and 2 plus h would be nothing. So if I square both of those amounts to get my y values, remember we're still in y equals x squared, so to get my y values I'm going to square my x values. So on top I've got 2 plus h squared, and I'm going to subtract 2 squared. And on the bottom I'm just going to subtract the two x's, 2 plus h minus 2. So if I expand the top, I've got that binomial being squared, and I remember that I have to FOIL that or use that rule. I can't just square each individual term. So 2 plus h squared is 4 plus 4h plus h squared. And then I subtract the 2 squared, which is 4. That all goes on top. On the bottom, I've got the 2 plus h minus 2. Well, the 2 and the minus 2, they subtract out, leaving me with just h on the bottom. Now let's see what else I can do to simplify this algebraic expression. Well, the 4 and the minus 4 on top can subtract out as well. So all I'm left with is 4h plus h squared all over h. And now I notice that every term has at least an h in it. So I can divide top and bottom by h. And if I do that, I get just 4 plus h all over 1, which is just 4 plus h. Okay, so as h approaches 0, that h that's sitting in that expression will go to 0, and all I will be left with is 4. So that's another way of figuring out that the slope between 2 and some other point that's really, really small, a small distance away, is going to approach 4 as the distance between those 2 points gets really, really small and gets really, really close to 0. So I can safely say that the slope of that tangent line that I've drawn at x equals 2, that slope of that tangent line is 4. Well, let's talk about a different x. Let's talk about x equals negative 3. And I'm going to use the same algebraic approach. Let's calculate the slope between x equals negative 3 and x equals negative 3 plus a little bit more, and I'm going to let that little bit get smaller and smaller until it approaches 0. So once again, to get the y values, I'm still dealing with y equals x squared. So to get the y values, I'm just going to square those x values. So on the top, I've got negative 3 plus h squared minus negative 3 squared. And then on the bottom, I'm just subtracting the x's, negative 3 plus h minus negative 3. So on top, I have to square that binomial properly again. And I get 9 minus 6h plus h squared. That's from squaring the negative 3 plus h, minus negative 3 squared would be just 9. And then on the bottom, I notice that the negative 3's subtract out again, so I'm just left with h. Focusing on the top, I again see that there's a 9 minus 9, and the 9 and the minus 9 can subtract out, leaving me with just negative 6h plus h squared all over h. Again, I can divide top and bottom by h, leaving me with just negative 6 plus h over 1, which is just negative 6 plus h. And then as h approaches 0, this approaches negative 6. So the slope of that tangent line at x equals negative 3 is going to be negative 6. And you can see that it's steep, you can see that it's negative, so negative 6 seems right as a slope for that red tangent line. So that's just a start of discussing instantaneous rates of change. If you have any questions, please let me know, and I will see you tomorrow.